Time is one of the most familiar yet mysterious aspects of our universe. We live our lives according to its ticking, counting hours, marking birthdays, and watching seasons pass. So it's natural to think of time as an unchanging, universal flow. In Newton's classical physics, this is exactly how time was understood. Absolute, constant, and the same for everyone, everywhere. In that view, time is like a perfectly even backdrop, moving forward at a steady pace, no matter what's happening in the universe. This simple picture made sense for centuries and was essential in building the foundations of science. But the 20th century revealed that time is far more complicated than our intuition suggests. Einstein's theory of relativity transformed our understanding of time by showing that it is not separate from space, but instead woven together into a single entity called spacetime. In this framework, time is not absolute. It can stretch or shrink depending on your speed and the gravitational forces you experience. This phenomenon, called time dilation, has been measured in real experiments. For example, astronauts on the International Space Station experience time passing slightly slower than people on Earth because they move at high speeds and are in a weaker gravitational field. Even GPS satellites need to adjust for these relativistic effects to function accurately. This shows that time is not the same for everyone. It's a flexible dimension shaped by the structure of spacetime. The possibility that time might be an illusion comes from both philosophical reasoning and modern physics. In the block universe theory, which arises naturally from relativity, all points in time, past, present, and future, exist equally. Our experience of time flowing is not an objective feature of reality, but rather a product of our consciousness moving through spacetime. In this view, the present is just one slice of a four-dimensional reality, and the future already exists as much as the past does. Some scientists and philosophers even suggest that the passage of time is similar to the way we perceive motion in movies. Individual frames are all there, but our brain stitches them together into a flowing sequence. In the realm of quantum mechanics, the question becomes even stranger. At very small scales, time is often treated as just a background parameter, a number that tells equations how a system changes, rather than a dynamic thing like in relativity. When physicists try to combine quantum mechanics with general relativity into a theory of quantum gravity, time sometimes disappears entirely from the fundamental equations, such as in the Wheeler-DeWitt equation. This has led to the hypothesis that time might not be fundamental at all, but instead something that emerges from the relationships between events, much like temperature emerges from the motion of countless particles. If this is true, time might not exist in the deepest laws of nature. If time is indeed emergent or illusory, it would mean our entire perception of reality is built on a convenient but incomplete model. The arrow of time, the one-way direction from past to future, could be a result of the universe as initial conditions, such as its extremely low entropy at the Big Bang, rather than a fundamental law. This wouldn't make our experience of time any less real to us, but it would change how we understand the universe at its core. Instead of a flowing river carrying us forward, time might be more like a static landscape that we traverse through our perceptions and memories. The ultimate nature of time remains one of the deepest and most fascinating puzzles in both physics and philosophy, and solving it could change not only science, but our entire understanding of existence.